Those volcanic flows on Mars might not be lava after all, but they could be mud. The northern lowlands and sedimentary regions of Mars are dotted with curious formations, tens of thousands of conical hills, many topped with small craters, and surrounded by deep channels scorched from the surface by flowing liquid. And that sounds a lot like volcanoes found here on Earth, but on a planet like Mars, where we cannot easily go to look, and where conditions can be so very different from Earth's, you have to be wary of making assumptions. The features on Mars may resemble Earth's lava flows, but there is also a type of volcano on Earth that spews up something completely different. Sludgy, oozy mud. Mud pots, as we know. The scientists have just found that under the very low atmospheric pressure and temperature conditions found on Mars, mud can flow very differently from Earth's mud volcanoes. In fact, it can look like a heck of a lot of like lava. And University of Manchester scientist Lionel Wilson explains we performed experiments in a vacuum chamber to simulate the release of mud on Mars. This is of interest because we see many flow-like features on Mars in spacecraft images, but they have not yet been visited by any of the roving vehicles on the surface, and there's some of an ambiguity about whether they are flows of lava or mud. Scientists have long thought that large amounts of water once flowed freely on the Martian surface, released for a very short period of time and eroding the landscape before drying up, or being covered by volcanic activity and sediments deposited by the wind. But sludgy sediments trapped under the surface could have later been pushed up and out by underground pressure, creating mud volcanoes, and this is what the researchers wanted to figure out. Their experiment setup consisted of a low-pressure cylindrical chamber 90 centimeters diameter and 180 centimeters in length, that's 35 to 70 inches. This was carefully pressurized at 7 millibars to simulate Mars atmospheric pressure for 15 experiments, and 1,000 millibars to simulate Earth atmospheric pressure at sea level for 6 experiments. And in both sets, mud was poured over sand, cooled at a temperature consistent with the surface temperature of Mars, which is minus 20 degrees Celsius. The researchers then studied and characterized the way the mud flowed across the surface. In terrestrial conditions, the mud flows did not expand, form an icy crust, or create lava-like flows, but the mud flows under Mars conditions did because of the lower atmospheric pressure. When atmospheric pressure lowers, so too does the boiling point of water, and that's why water boils at a lower temperature at higher altitudes. And if you were to find yourself floating in space without protective gear, saliva would boil right off your tongue, among other more fatal things. The effect on mud flows in simulated Mars conditions is fascinating. The water in the mud begins to boil and evaporate, and that process absorbs the latent heat from the vapor. This cools the mud, and a crust freezes on the surface. The planetary scientist Ernst Huber of DLR Institute of Planetary Research in Germany said, "Of course, we already know that the liquid water begins to boil sooner under lower pressure. However, the impact of this familiar effect on mud has never been investigated in an experiment before. Once again, it turns out that different physical conditions must always be taken into account when looking at apparently simple surface features on other planets, and we now know that we need to consider both mud and lava when analyzing certain flow phenomena. And what happens after the crust freezes is where it gets really good. The mud flow behaves like Pahoho lava flow seen in Hawaii and Iceland. The mud still pushes up from underneath, erupts through the icy crust, oozing out and refreezing into a new flow lobe. And with all the process, while the process is similar, the shape of the mud flow is different, the researchers found. And while there are limitations to the study, Martian gravity could not be replicated, for instance. The research does not show that mud volcanism would not be impossible on the red planet after all. And the research has important implications for other kinds of volcanism in the solar system, such as the ice volcanoes thought to exist on far objects such as Titan and Pluto. It shows that even though we may think we understand what's going on, there could be environmental conditions that change the processes in fundamental ways. As geophysicist Peter Brosz of Czech Academy of Science says, our experiments show that even a process as apparently simple as the flow of mud something that many of us have experienced for ourselves since we were children, would be very different on Mars. The research was published in Nature Geoscience, and this is on Science Alert by Michael Starr. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.